Here's Algebra 2, Lesson 3. It's the rules of exponents. So you're supposed to know these from your Algebra 1 class, but I noticed, we were doing some problems like, or maybe that was the pre-calc class. Anyways, problems like this will show up, and it gets a little tricky, gets a little messy. So I'm going to go back over these rules as a refresher for you. So what this is saying in the little box is if you had like x to the negative squared, that would be 1 over x squared. Taking a reciprocal will change the sign of the exponent. So we'll talk about that more. The way your book works is these little blue boxes. Those are kind of the formulas for you. Okay, so there's a product rule. If you had let's say you had x squared times x to the 5th. Well, all you'd have to do is add the 2 to the 5 and you'd have x to the 10th. So that's called product rule when you're multiplying. When you're multiplying, you add the exponents. And then this one on the bottom is the power rule. So when you are taking a power of a power, like if I had x squared cubed, I would actually multiply them. So that'd be x to the 6th. And if you guys, like in class, if you don't end up understanding this, just ask some questions. But I'm just going to kind of go, I think I'm going to actually just do some problems for you. I might even do some of your homework problems for you. And then we'll talk about scientific notation. So first, I think I'll just do a few of your homework problems for you for free. Free homework help. Okay, so this one, my book has a little mark in it, but this is 1 over 2 to the negative 3, and my first rule of exponents tells me if I want that little negative 3 to be positive, I can do a flip or take a reciprocal. So I'm going to say that 1 over 2 to the negative 3, that's equal to 2 cubed over 1, right? And that's just equal to 2 cubed. That's 2 times 2 times 2, and that's 8. Okay, so whenever you see an exponent, and let's say it's in the denominator and you don't want it negative, you can just pretty much flip it up to the numerator. That's the way I think of it. I think of it as it was down there, and then I think Mr. Fukumoto used to say something funny. He used to say it lived in the downstairs apartment, but it had a negative attitude. It wasn't happy. So as soon as it moved upstairs, then it could have a positive attitude. Okay, so if they're unhappy, make them go to the other side of if they're negative, make them go to the other side of the fraction bar. Okay, let's do letter B. 2 to the negative 4th. Okay, so 2 to the negative 4th. So I can write it over 1, and then see he's unhappy in the upstairs apartment, so I'm taking the reciprocal. So that I'm going to say it's 1 over 2 to the 4th, which equals 1 over 2 to the 4th is like that. 2 times 2 is 4 times 2 is 8 times 2 is 6. That's 1/16. So hopefully you get the idea. I'm going to do one more. I'll do letter C. And then I'm going to do maybe one of these more involved ones. And then I'm going to talk about scientific notation. So if I have negative 2 to the negative 2, I'm going to be careful. I do not have parentheses around my negative 2. So the base is just 2, not negative 2. Okay, so the base and the exponent, they're going to move to the opposite side, or in other words, I want to take the reciprocal of this thing, which would be, I'm going to put the negative sign out here, because it's not part of the base. It doesn't have parentheses. See how it turned positive when it changed from the numerator to the denominator. And that's negative 1 over 2 squared is 4. Okay, now I'm just going to do one of the really kind of hairy ones. I'll do letter H. I'll write it down and then I'll put it where you can see it. It's y squared to the negative 3 times x to the 4th y to the 4th. Okay, I wrote it all down. Hopefully I wrote it correctly. And we're going to work this one out. So there's different laws over here. I don't know if you can tell the difference between the blue and the... I have them written in blue. I hope that shows up. This looks like the product rule. So it says that I have to multiply the exponents. So 2 times negative 3 is a negative 6. Now don't think there aren't other ways to do this, because there are many other ways to do this, but I'm just going to kind of show you one way to do it. Now this one, I'm going to multiply it out to each of the two variables that are inside the parenthesis. It's kind of like I'm distributing. So that's going to be x to the negative 2. And then negative 2 times negative 2 is positive 4. And then down here I still have my x, y to the 4th. Now I know you're dying to cross out these x's, and we'll get there in a second. Okay. Now I don't really need these parentheses anymore, because all that says is just we're multiplying everything all together. So actually what I think I would do first, if it was my problem, and it is my problem, is I'd get the y's together. Now this rule right here says when I'm just multiplying stuff together, I can add the exponents. So I'm going to add negative 6 and positive 4. And then I'm going to add the 4 and the negative 2. And I'm going to leave this down here. And finally, I'm going to cancel stuff out. So that there, x squared is like x times x, so one of them will cancel out with this bottom. And that'll just leave me x on the top. And then these two y squares are going to cancel out with two of those. And there's going to be y squared on the bottom. That's what I got. Now maybe I'll give you a prize. If I made any mistakes and you let me know, I'll give you some extra credit or something. Okay, so I only have a couple minutes to show you scientific notation. So I'll just do letter J. Scientific notation. We're just going to use the laws of exponents on it. I'm hoping that you remember what scientific notation looks like. Basically, to have stuff in scientific notation, you want one non-zero digit to the left of the decimal. So in other words, I'd have to move this all the way over 1, 2, 3 to the right. So I'm actually going to write it in scientific notation. I'm going to write it as 4.0. I moved the decimal 3 to the right, so it's going to be times 10 to the, I know this sounds weird, but since I took the liberty of moving it 3 to the right, I'm going to have to multiply it by 10 to the negative third for it to kind of make up for the fact that I moved it 3 to the right. This will be, if I want my decimal in between the 6 and the 0, I would have to move 2 to the left. Oh, how do I say times? Here, I'll go like this. Since I took the liberty of moving it 2 to the left, I have to add 2 to my 10 to this. So now, like that. I'll explain this better in class because, or I'll take questions after I might show this in class. This one, if I write it as scientific notation, it has to be 3.0 times 10 to the something. I have to move 1, 2, 3, 4 places to the left to make it 3.0. To make up for that, I'm going to add, what did I say, 4 to this number, so I think that'll be negative 8. And then the next one's going to be 1.0 times 10 to the, I have to move 1, 2, 3, 4 to the right. To make up for it, I'm going to have to take 4 away from here, so that'd be -1. Okay, well now I can just do all this multiplication, like 6 times 4, that's 24. And then this and this, I just add the exponents up. 3 and -3 and 11 makes, alright, and then 3 times 1, that's 3, and add these up. -9. 24 divided by 3, that's 8. Bring this 10 to the -9 up, because it's unhappy down there. That'll be 10 to the 8th times 10 to the 9th. That makes 10 to the 17th. Okay, and I'll give you some extra credit if you catch me in a mistake.